Alright, here we go. We are going to start semester exam fall 2019 review part 2. Okay, so let's look at this. Let's go from here. We've reviewed all through problems 1 through 19. So now let's get ready to look at number 20. This should be pretty easy. You only got to identify a parallel segments. Okay, so like, AD could be parallel to EH, or it could be parallel to BC, or it could be parallel to FG. That should be hard. Those should be fairly easy. Keep in mind, segments, we want 2 points. If I wanted a plane, I would want, say, at least 3 points. You can give me 4 points. Kind of go from there. And keep in mind, parallel, skew, what else? Intersecting, those type of things. All right, so maybe add those definitions to your formula sheet. Okay, so for problem 21, like I would use this type of drawing, but make sure you understand what are corresponding alternate interior, alternate exterior, consecutive, linear pair, and vertical. You should know those things, so that should help you answer those type of questions. So let's look at problem 21 and 22. Okay, so based on the definitions you had here, you can see that angle 3 and angle 5 would be alternate interior angles. And again, that's something you should just have. Make sure you understand the type it is. But that should be that right there. And there you go. Complete the sentence. When the parallel lines are cut by an inversal, the angles formed are either going to be congruent or supplementary. So keep in mind, let me respell this. Hold up. There we go. Okay, so keep in mind when you go over here, at this point, unless we don't know anything, but once we go to that they're parallel, then all of a sudden when we have parallel, then corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Consecutive, though, add up to 180. A linear pair add up to 180. Verticals are always congruent. So kind of, make sure you remember that. Why does that become important? Look at the next ones. So like a problem like number 23, we want to find the measure. Well, these are alternate exterior angles, so I can say 4x is equal to 3x plus 20. And again, variables to the left, numbers to the right. There are no numbers to go to the right. So this is just x equals 20. So they want to find the measure of FDE. So I would put the 20 here. 20 times 3 is 60. And then 60 plus, that should be a plus, 20 would be 80. So here, angle FDE is equal to 80 degrees. I guess I could put here measure, but there you go. All right, so you get that. Okay, so for 24 and 25, what I'm saying here is this. Look, what do these two mean? What are those two? Those are alternate exterior angles. That's all that is. That's what you just need to tell me. If they're alternate exterior angles, that would be, there's a postulate or theorem that will allow us to show that if they're alternate exterior angles and those are equal, then the lines would be parallel. That's all you got to worry about there. Don't overthink that. Don't overlook that. Yeah, we'll be fine. All right. If angle 2 is equal to 4x and angle 6 is equal to 3x plus 25, what value of x makes them parallel? Again, keep in mind that these are corresponding, so that means they need to be equal. So 4x is equal to 3. Ooh, these are way too easy for the solving, but you get the idea. So minus 3x. So x here equals 25. That should give you a value where basically they would have the same angle, and then you would be able to say that they're going to be equal. Since they're going to be equal, the lines would be parallel. So there you go. Alright, so you might need this for your formula sheet. The slope formula is equal to m, the slope is equal to the subtract the y's over subtract the x's. Remember, the main idea here is that it's subtract the y's over subtract the x's. It doesn't matter if it's y2 minus y1 or over x2 minus x1 or y1 minus y2 over x1 minus x2. I always prefer the first minus the second. That just makes more sense to me. Also keep this in mind that if I say x equals a number, just x equals a number is an equation, because you should remember your y equals mx plus b. That you should know. And of course there's your slope and there's your y-intercept. But Keep in mind, x equals a number, the slope is undefined, and that's a vertical line. Y equals a number, the slope is 0, and that's horizontal. So let's look at the next questions, shall we? All right, so on this one, we want to say, okay, find the slope of jk through 1, 1, and 2, 3. Again, like what I do is I say here, like, subtract. Notice I always write the subtractions. I always write the fraction first, then I put in the numbers. So y's are on top. So 1 and 3. Again, like I said, I like to put the y first one first, second one second. That made more sense to me. And then 2 minus 1. Oh, nope, sorry. 1 minus 2. Wow, no, let's not go there. All right, so 1 minus 3 is -2. This is -1, which would give me 2. And again, if you type this into the calculator, it will go straight to that answer. Okay, control divide. I forgot how to put divide symbol. Control divide will allow you to say type that in to where you can have this fraction, and then you could like type that in and just press enter, and you'll have your answer. All right, true or false? The graph of x equals 5 is a vertical line. Well, again, if you look at the formula thing that I just gave you, x equals a number is a vertical line. So the answer is 2. All right, parallel. Okay, again, parallel, same slope. Intersect or coincide. Not sure. Be ready for perpendicular, and I'll talk about that more in a second, and parallel, and then just intersect. But obviously these two have the same slope, so this one is parallel. Okay, so again, parallel, same slope. Obviously, like if you had one is equal to 3, then the other one would be equal to 3, something like that. But opposite reciprocal, keep in mind that if one equals 3, then the other one equals -1/3. Maybe you give yourself some more examples. Ugh, that's a horrible third. Okay, but you get the idea. So keep that in mind. Make sure you understand that and kind of go from there. So let's look at the next ones. So we're trying to here determine whether the line through 0, 4 and 2, 0 and the line through negative. Okay, so compare the two slopes. So I'm going to do this one, slope number 1. Slope 1. Okay. So here, 4 minus 0 over 0 minus 2 would give you 4 over -2, which is -2. Okay, that's slope 1. Slope 2, and this one would be 3. Let me get like that. 3 minus 2, and then -2 minus a -4. Type that in. You get 1 over 2. So 1/2, because that would become 1/2. So 1/2, -2, that means these two are perpendicular. Perpendicular. Okay, what type of slope does this one have? It has a positive slope. You should be able to recognize that. That's positive. Negative would go down. 0 is horizontal. Undefined is vertical. So maybe you add that to your formula sheet. Maybe, I don't know. Let's find out, shall we? Okay, now we're getting into some of the fun stuff, right? Okay, so like for a problem like 31 and 32, classify A, B, D, A, B, D. Well, you see this like right there? That's a right angle, so that's a right triangle. And classify A, B, C by its lengths. That would be equilateral. So again, let's keep in mind here, what do we want? So again, there's different ways we can classify triangles. We can classify them based on angles or based on sides and combine that together. Again, acute, remember, the acute is all angles less than 90. 90 degrees, okay. But keep in mind that an equal angular is also acute, but all angles are 60 degrees. So be careful on that, because a lot of you on that one test, y'all would put acute because you saw 60, 60, and like 60, but that was technically an equal angular. So keep in mind that some acute could become equal angular, but only in special case. They all have to be 60. Obtuse, one angle is greater than 90. Greater, I can't write, than 90, okay? And then a right triangle, of course, one angle is 90 degrees. Okay, scaling, all sides different. Non-congruent, and we'll say different. And then isosceles, two sides congruent. Equilateral, all sides congruent. So, I mean, these are things you should know, but if you feel like you need to add that into your formula sheet, then add it into your formula sheet, and you'll be fine. All right, so let's look at the next one. Okay, so how do I find the value of x? Well, keep in mind that if these two sides are equal, then these two angles are going to be equal. So this is also a 2x. And then, again, what do we know? All three angles of a triangle add up to what? What is that? 180 degrees. Yes, you are correct. So I can say here 3x plus 5 plus 2x plus 2x. Add those up, you get 7x plus 5 is equal to 180 degrees. Okay, so I have 7x is equal to 175, and then I divide by 7, and I get 25. Yes, so x here is 25. And there you go. Yay! Alright, I would add in here, like, what is side angle side? Give yourself examples, like, say, side, angle, side. That could be different there. But comparing it to another triangle, side, angle, side, and that means the two angles would be congruent, okay? Side, 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 you went doot, 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 something like that. Doot, 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 dun, 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 type of thing. Angle, side, angle, and I always start from the top. I don't know why I'm starting on top. But okay, so angle, side, angle, an angle, a side, and then another angle, an angle, a side, and another angle. So notice how the side is in between those two versus angle, angle, side, like angle, angle, side, doot, 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 angle, angle, side. And then keep in mind that the HL one is the one with the 90 degree. Doot, doot. I ran out of space. Okay, let's try HL over here because I was running out of space. HL, you got to have a 90 degree angle, doot, doot, and you need the hypotenuse and its leg to be equal. So here, a hypotenuse and a leg to be equal. Okay, so you can look those back up maybe and add those in, and that should help you get started with the next ones. 34, what value of x? Okay, so keep in mind that when we're saying side angle side, we're trying to say that everything, all the sides and all the angles are congruent. So that means then this has to be equal to that. So here I'm saying 4x plus 3 equals 27. And then you solve, you subtract the 3, divide by 4, you should get x equals 6. And that's it. That's all you're saying. So that, by doing that, then what you're saying is that this would equal this, and thus that would be like that. Doot, doot. And that would give you side angle side. Now, if I have, let's say these two are equal, okay, then they're saying if AB is congruent to DE, what additional congruence statement is needed to do side by side, 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 side? Okay, so I've already got this side congruent with this one. I've already got this one congruent. So what's left? I need AC to be congruent to FD to work that one. Okay, and I guess make sure you pay attention to the way the lettering might be, because maybe you'll be off. Like maybe it says, like, if I go AC, I should have said DF, but you get the idea. Okay, I wasn't able to get like the picture for 39 in there, but that's okay. We'll work from it there. All right, if AB is equal to 3x, so AB is equal to 3x minus 7, and DC is equal to 2x plus 1. What value of x proves? Okay, so all that's trying to say is we want these to show that they're equal. Okay, so again, here I would say 3x minus 7 is equal to 2x plus 1. Variables to the left, numbers to the right, and that should give you x equals 8. Once you do all that, you should have x equals 8. It's pretty simple, right? All right, so then I would look at the next one, number 37. What postulate or theorem proves that AED is congruent to CEB? Okay, so what you see here in those two, you can see that you've got these sides congruent. So you have a side and a side. So what else do I need? I need either, if I go back, if I've got two sides congruent, I either need side angle side or side side side. That's what I need. So if I go over here, I look, well, what can I do to prove this? Well, don't forget, and this is where we come back to other stuff. Vertical angles are congruent, always. So that gives me side angle side, so I can prove this one by side angle side. So you look for something like that, where you can prove those things and see it quite easily. All right, let's look at number 38. 38 says if our angle DAB is congruent to ADC. So DAB, is congruent to ADC. What congruency statement do you need to prove DAB, so this top thing right here, is congruent to, say, ADC. So then that would be this one right here. Okay, so if that's the case, let's see here. Ooh, that becomes interesting. Let's look, just a second. Okay, so for me, what I did was I drew this out to see this a little bit better. And again, remember, we want to do this by angle side angle. Okay, so this is like, say, A, D, and B, but this is A, D, and C. And look, I've got an angle, a side, so I need another angle, which means it has to be this one right here. That's what I would need. So I would need like angle ADB to be congruent to angle DAC. Now, again, keep in mind this is multiple choice, so stuff like that should be easy, but pay attention to what they're asking you to look for, and that should hopefully make that a little bit easier. All right, I'm going to do one more, and that will be finished for this one, and so let's go from there. The last one says if angle ABC and CDA, ABC and CDA are right angles, sounds like we have HL here, and AB is congruent to CD, what postular theorem could prove ABC is congruent? Okay, so now look here. What you have, if you look at this triangle ABC, I'll draw it like this. That's this and this are congruent. That's ABC right here. Okay, and then CDA, that it just helps me so much if I can draw it out like this. That's what I do. Okay, and that's congruent. Okay, so what do I need? If I wanted to, the easiest thing, obviously, this right here, they both share that, AC, and that would be congruent. Well, what does that prove? That's the HL. Remember, that's the one with the right angle. So the HL theorem would prove that one to be correct. Okay. Anyways, that is it for today. That is it for part 2. Hey, y'all are getting there. Thank you for listening to me so much. And we will get that part 3, and you will be ready for the semester exam. And y'all are going to do awesome. Thank you so much for your time. Y'all take care.